Welcome to the Electrolube booth here at Productronica. Delighted to be joined by Phil Kinner. Nice to see you again, Phil.
You too, Trevor.
So I believe you're launching this week a new UV curable conformal coating. Tell us a bit about it and what its key features are.
Okay, so the driver for high volume manufacturing has really been about UV curing technology. Traditional products have had some limitations both in terms of performance, but in terms of curing in areas that are shadowed from the UV light. With this product we've addressed both those issues, so we can get good coverage on component leads, which is really important for condensation resistance testing, things like this. We can survive the thousands of thermal shock cycles due to the flexibility of the material, and the chemical cure aspect of the material means that it's fully cured within 6 hours, rather than with the moisture system. The answer is, how long is it going to take to cure? It depends. Every engineer's favourite answer. So yeah, within 6 hours, it's fully cured. That's right.
It could take a week with the other ones sometimes. Yeah, that's right. So it's using a standard UV system. Does it need any thermal heat?
No, it doesn't need any thermal heat. It'll cure with LEDs or microwave arc lamps. It doesn't. Either is perfectly acceptable, which is unusual. Most materials it's one or the other. But no, I mean, once it's applied, then the UV's been initiated. It's going to cure regardless of any other factors. And
what about the viscosity and the coverage over the board? What's it like?
So the material is designed to be spray applied, and with a careful focus on the viscosity and rheology to ensure that we get optimum coverage and encapsulation of component leads and any other metal surfaces that we're looking to protect.
Yeah, edge definition and that type of thing.
Yeah. I mean, obviously, that depends a little bit on the design of the board, but the edge definition is good, but there's always the option to use a needle to tidy any other areas or to get in at inaccessible areas. So it's giving the end user the maximum amount of flexibility to coat their boards to the level they need to get their performance requirements.
Great. Okay. So that's available now. What principal applications are you using this for?
The target is really automotive due to the performance requirements, but it's suitable for any high volume or medium volume or even low volume application where people just want a high performance material and they like the idea of UV curing.
Okay, great. So is this manufactured in the UK or in India, or which of your plants are you doing this in?
So as always, we manufacture, so it's designed and developed in the UK, primary manufacturing site, but we have backup capabilities in our Chinese and Indian plants as well. So whether it's Brexit or any other issue, then hopefully we're covered.
Yeah, great. Okay, well, thank you for giving us some information on that, Phil. We're going to join your partner Alistair in a moment, and he's going to tell us a bit more about a couple of other new products from the Electrolube stable.
Excellent.
Thank you. So now we're joined by Alistair Little, who is the Global Business Director for the Resins Division. Nice to see you, Alistair.
A pleasure to meet you again as well.
Two new products we're going to look at, Alistair. The first is a filler product. Can you tell us a little bit about it and why you developed it?
Basically, the gap filler, it's called GF400, is designed to, excuse the pun, fill a gap in the market. So it is a 4 watts per metre Kelvin thermal management product. It is a 2-component system which allows us to enable the material to be fully cured, so to prevent flow out, slumping, or any of this sort of problems associated with the traditional pastes. And it's aimed primarily for the automotive market, so they're looking for that higher performance level across a wide range of temperatures, so it can go up to 150 degrees centigrade without any problems and down to -50. It's very easy to apply. It's as I say, a 2-component system, 1-to-1. It's available in a range of different packaging formats, and so can be applied either as through conventional dispensing equipment, or can be used through, like we do a small 50 mil side-by-side cartridge, which can be effectively hand applied for small prototyping runs.
And as you say, it's a two-part material, and it cures in air.
Yes, it's standard room temperature cure, although you can also then elevate the temperature to 60 degrees centigrade to speed up the cure time.
What sort of cure time are you getting out of it?
For room temperature, you're normally talking somewhere in the region of about 4 to 6 hours, so that you can get it to a handleable state. And when you get to 60 degrees centigrade, you're talking about an hour, 2 hours.
Okay, that's useful. Right. So the other new product you've got here this week is a resin product. Can you tell us a little bit about that?
Again, it's been aimed primarily for the automotive market. It's a two-component polyurethane system where we've been progressively pushing up the standard operating temperature. So now we have a continuous operating temperature maximum of 150 degrees centigrade, and it will withstand excursions up to 160 degrees centigrade. It is a low viscosity resin. It's got very good chemical resistance against everything from conventional water to various solvents, petrol, diesel, brake fluid, AdBlue, and also for acids and alkalis. As I say, it's been developed for the automotive market, but the automotive market is in a bit of a transition phase where we're swapping over from the traditional internal combustion engine to electric drivetrains. And to be honest, we're in an area where people are not really sure what chemicals are going to be used in the automotive industry in the next 5 years, let alone what's going to happen in the next 10, 20 years. Right. So things are in a bit of a flux in terms of what do we actually need from a resin. And for that end, we have developed a resin which has all the standard normal electrical performance properties, as well as we've increased the temperature performance, and also broadened the scope as regards chemical resistance.
So, I mean, when you're talking about the flux that the industry is in at the moment, I mean, are you going to need a different sets of materials, obviously, if we go fully electric, or continue to go fully electric, or whether we stick with hybrid type cars?
At the moment, it's a case of nobody really knows. Right. At the minute, the hybrid vehicles, electric vehicles are all running on batteries. Mm-hmm. But when we move over to fuel cells, nobody really knows what that technology exactly entails at the moment. Yes. We don't really know what the fuel is going to be. It could be hydrogen, that is the current favourite. It could be methanol. Right. Nobody knows 100% which way it is going yet, which makes life very interesting.
Right. Absolutely could. It absolutely could. So it'll be interesting to watch that and see how it develops. Alistair, for the moment, I want to thank you for telling us about the new products, and thank you for joining us today.
A pleasure. Thank you.